Hello everyone, welcome to my channel Physics Tricks. So let's start with Kinematics DPP 5, and in this we have first question. A particle travels half of the distance of a straight journey with a speed 6 meter per second, and the remaining part of the distance is covered with a speed 2 meter per second for half the time, and remaining journey and with a speed 4 meter per second for other half time. Average speed of the particle. So the total distance d he has covered in three parts. In the first half of the journey, that is d by 2, it travels with the speed of 6 meter per second, and next distance d by 2, it travels with two intervals, that is t by 2 and t by 2, with a speed of one is 2 meter per second, other one is 4 meter per second. So we know that for same time, average speed we have, and that is equal to v1 plus v2 divided by 2, which is equal to 2 plus 4 divided by 2, that is 6 by 2, that is equal to 3 meter per seconds. That indicates he has travelled d by 2 with a speed of 6 meter per second and other d by 2 with a speed of 3 meter per seconds. Now here the distance is same. So if the distance is same for same distance, the average speed we have, and that is equal to 2 v1 v2 divided by v1 plus v2. Now what is v1 and what is v2 over here? As you can see, v1 is 6 and v2 is 3. So 6 plus 3 is 9. So if you just calculate this, you will get, this is 3 3s are, 3 2s are, so 4 meter per second. So answer for this question is 4 meter per seconds. Next question we have. A particle starts with initial speed u and retardation a to come to rest in time capital T. So over here it is given a particle starts with initial speed u and the retardation a and comes to rest in time capital T. So total time for the distance d is capital T given. We want the time taken to cover first half of the total path. So d by 2, let us consider time is t. So therefore for the first half, that is d by 2, initial velocity is u, time is t, minus 1 by 2 at squared. Why? Because retardation given. And for the full journey, d is equal to u capital T minus 1 by 2 at squared. I applied over here the second equation of motion. Now instead of d we can put 2 ut. From this we can calculate the value of d, and that is 2 ut minus at squared. Now put it over here, so you will get 2 ut minus at squared is equal to ut minus 1 by 2 at squared. Now by first equation of motion, final velocity 0 is equal to initial velocity u minus a into capital T. So from this, what is u? A into capital T. Put this u in this equation, we'll get 2 a capital T small t minus at squared is equal to at squared minus 1 by 2 at squared. Now take a common from both the equations, we'll get 2 capital T small t minus t squared is equal to t squared minus t squared divided by 2. Multiply by 2 throughout, you will get 4 capital T small t minus 2t squared is equal to 2t squared minus t squared. And if you just solve this, you will get t squared minus 4 capital T small t plus 2t squared is equal to 0. Now this equation this equation is quadratic in small t. So it is 2t squared minus 4 capital T small t plus t squared is equal to 0. So this equation is quadratic in small t. We can have the equations t1 comma t2, and that is equal to minus b as in 4t plus or minus square root of b squared, that as in 16t squared minus 4ac, that is 8t squared, divided by 2a, that is 4. So if you just take the t common from the above, it will be 8t squared divided by 4. So we'll have 4t in bracket 1 plus or minus root 8 divided by 4 divided by 4. So 4 get cancelled. We'll get from this t in bracket 1 plus or minus root 8, as in we can write root of 8 by 16, 4 as in 16, isn't it? So 1 plus or minus, this is 1 by root 2. So over here the answers are t1 comma t2 we have, and that is 1 plus 1 by root 2 t or 1 minus 1 by root 2 t, and this is given in option 2. So I hope this is clear, all of yes. Now the third question. A stone is dropped into a well and the sound of splash is heard after 5.3 seconds if the water is at a depth of 122.5 meter from the ground. Find the velocity of sound. So this is the depth of a water supposed to be, and that is given 122.5 meter. One stone is dropped into this water. So for this stone to go down, it will take a time t1 supposed to be now, and once it will be inside the water, the sound of splash will be heard by the man after some time, right? So this time is t2 supposed to be. So t1 plus t2 is the total time, and that is given 5.3. Right, now t1 is the time of fall. Time of fall, we know that time of fall is equal to the root of 2h divided by g. So we have, this is root of 2 into what is h, 122.5 divided by 10. So if you just solve this, you will get, just a minute, I'll solve. This is 122.5 into 245 divided by 10, so which is equal to root of 24.5. So 24.5 root, if you take root of 24.5, it is 4.94 seconds. So this is the time of fall. So t1 is 4.94 plus t2 is equal to 5.3, and if you find out the time, it will become 5.3 minus 4.94. If you subtract this now, 5.3, you will get 0.35. This is the time for a sound to go towards the man. So time is nothing but, in terms of distance and speed, is time we have t2 is equal to distance by speed. The speed is speed of sound. So speed of sound we have, distance it has to travel is 122.5, in time is given 0.35. If you just calculate 122.5 divided by 0.35, you will get 0.35, you will get 408.3 meter per seconds. 408.3 meter per second. So I hope this is clear. So answer for this is 408 meter per second. Next, a body is released from height h above the ground exactly at the midway. If g vanishes, find its total time of fall. Okay, so over here this is the body which is dropped from height h. Exactly at the middle, g vanishes, indicates after this body will go with the same speed. Whatever speed at this point will go with the same speed till h by 2. Okay, so this is h by 2. In this g present, in this g is equal to 0. Vanishes indicate 0. So whenever acceleration 0, that time body in motion will remain in motion. Okay, now so that body will not stop, it will remain in motion with uniform speed. Okay, now what is the time required for the body to travel a distance of h by 2? So that is the time of fall. We have root of 2h divided by g, but h over here is h by 2 divided by g, so which is root of h divided by g, because this 2 will get cancelled. Now how to find t2? T2 is whatever the speed we have and the distance is h by 2 into speed. Now what is the speed? It is root 2g h is h by 2, so which is root of 2 into g into h by 2, so 2 get cancelled, h divided by 2 root gh. Now if you just calculate time t2, we'll get 1 by 2 root of h divided by g. So total time we have, therefore total time is equal to t1 plus t2, which is equal to root of h divided by g plus 1 by 2 root of h divided by g. So that is 3 by 2 root h divided by g. So this is the answer which we have for this fourth question. Now the next question. In this fifth question, as you can see, a parachutist drops freely from an aeroplane for 8 seconds before the parachute opens out. Then he descends with a net retardation of 2 meter per second squared, reaching the ground with a velocity 6 meter per second. Find the height from which he falls out of the aeroplane. Okay, so one parachutist given and he falls freely, indicates initial velocity is 0, right, in the downward direction, and he falls freely for 8 seconds. After that, he'll have the net retardation of 2 meter per second squared, and at this point we have to calculate what is the speed, and finally he reaches the ground with a speed of what is called as 6 meter per second. So this is h2 and this is h1, so we have to find total height. So here total height is h1 plus h2. Firstly find out h1. h1 we have u is 0, half into 10 into t squared, that is 64. So if you just solve this, you will get 320 meter. So after 320 meter, he opens out his bell, and after that he'll have the retardation. So what is the speed at that point? Speed at 8 seconds, speed at 8 seconds you can have, and that is v is equal to u plus at. V is 0 plus a is 2 into t is 8, so which is equal to 8 to the 16 meter per second. Sorry, over here a is not 2, a is 10. A is 10. Why? It's in free fall, so it must be 10. 10 into 8 we have is 80 meter per second, right? 80 meter per second in the downward direction. So this is 80 meter per second. This is 6 meter per second. Now, if we know the final velocity, initial velocity, and the deceleration, we can find out the height, and that is 6 squared final velocity is equal to initial velocity 80 squared plus 2 into a is minus 2 into s is h2. So if you just calculate 6 minus 80, 6 plus 80, because we have 6 squared minus 80 squared is equal to minus 4 h2. So h2 we have is, this is minus 74 into 86 divided by minus 4. If you just calculate this now, we'll get, this is 74 into 86 divided by 4, it is 1591. And we want the total height. So total height we have, and that is equal to h1 plus h2, and that is equal to 320 plus 1591, which is equal to, this is 1, this is 1911. So indicates 1911 meter. So he falls from the height of 1911 meter. So I hope this is clear. Now the next question, sixth question we have. Two balls are dropped to the ground from the different heights. One ball is dropped 2 seconds after the other. So two balls are dropped from the height, different heights is given. This is h1 and this is h2. So this must be the first ball and this must be the second ball, so that these two balls will reach the ground at the same time. If we consider this as first ball and this as second ball, they will never ever reach the ground at the same time. Okay, so that is the reason the ball which is at higher height will be the first ball, and ball which is at the lower height will be the second ball. Okay, so this is the first ball, this is the second ball, and it is given 5 seconds after the first ball drop. So this time required for the first ball is 5 seconds given, and after 2 seconds, that means for this ball it is 3 seconds required. Okay, so what is the difference in height? So difference in height we have is h2 minus h1. What is h2 now? 1 by 2 gt squared. T squared is firstly time required for this t1 supposed to be squared, minus 1 by 2 g t2 squared. So 1 by 2 g common, it is 5 squared minus 3 squared. So it is 9.8 into 5 minus 3 is 2 into 5 plus 3 is 8 divided by 2. So 2 get cancelled. If you just find out this, you will get 78.4 meter. So the difference between the height, this one is 78.4 meter. And they want what is the height of first ball. Height of the first ball you can directly find. h2 is equal to 1 by 2 into 9.8 into 25. If you just calculate, you will get 122.5 meter. So I hope this is clear. It's very simple. Now the seventh problem we have. An object falls from a bridge that is 45 meter above the water. So one object which is falls from a bridge which is 45 meter above the water. Okay, no problem. If it falls directly into the small rowboat moving with constant speed. Okay, so one small boat which is moving with a constant speed, it falls directly into it, which is at a distance of 12 meter from the point of impact. Okay, so what was the speed of boat? So see here, whatever time of fall is there, right? So this is the time of fall, we can say time of fall, and whatever the time required for a boat to reach at that point must be the same. Then and only then required for a boat to reach the point of impact, isn't it? If this two is same, then and only then this ball will fall into the boat, isn't it? Right now, so therefore we can write distance traveled by the boat is 12 is equal to speed v into time. This time and the time of fall must be the same. So 12 is equal to v into, what is the time of fall? Root of 2h by g. 245 divided by g is 10. So 12 is equal to v into, this is 90 divided by 10, that is root 9. So therefore we can say v is equal to 12 divided by 3, that is 4 meter per second. If the speed of the boat is 4 meter per second, then and only then this ball or this object falls into the boat. So I hope this is clear. Now the 8th question. A body falls freely from a height of 25 meter. After 2 seconds, gravity ceases to act. Find the time taken by it to reach the ground. So see here, a body falls freely, it is given. And after 2 seconds, gravity ceases to act. Ceases to act means what? Gravity disappears. 0 meter per second squared over here. Over here, G is 10 meter per second squared. Right? Okay. And we want what is the time of fall. So total time required to reach the 25 meter distance. Now in 2 seconds, what is the distance travel? How to find? It is half G into T squared. G is 10 into T squared is 4, which is equal to 20 meter, as you can see. So in 2 seconds, it will travel a distance of 20 meter. So what is the left out distance we have? 5 meter. It will travel with what? This distance it will travel with constant speed. Why? Because in that gravity is 0, acceleration is 0. So therefore we have time is the speed, right? Distance firstly 5 divided by speed at that point. How to find speed? Speed is v is equal to u plus 80. 80 is 10 into 2, 20. So which is 1 by 4. So t we have is 0.25. So this is the time required for a body to travel a last 5 meter distance. So therefore total time we have is 2 seconds initially, finally 0.25, so 2.25 seconds. So I hope this is clear. Now the next question. If a freely falling body covers half of its total distance in the last second of its journey. Okay, so if a freely falling body covers half of the total distance, so total distance we have is h, and half of the total distance indicates this is h by 2 in 1 seconds. So we want what is the time of fall. So total time we want, right? Time of fall we want. Okay, so now to find the total time of fall, we have therefore h is equal to ut plus half at squared, but half a over here is z into t squared, right? And in the last second, that is h by 2 is equal to, we have u is 0, so 1 by 2 g 2t minus 1 in the last second, right? This t is total time of fall. So h, put it over here, this 2 will get cancelled. We have 1 by 2 g t squared is equal to g 2t minus 1. So this g get cancelled. We'll have t squared is equal to 4t minus 2. So t squared minus 4t plus 2 is equal to 0. And as you can see, this is the quadratic equation. And you can easily find the roots of this quadratic equation, t1 comma t2, which is equal to minus b, that is 4, plus or minus square root of b squared, that is 16, minus 4ac, that is 8, divided by twice a, that is 2. So which is equal to 4 plus or minus square root of 8 divided by 2. So if you just solve this, you will get, this is 1 plus or minus, so this is 2 plus or minus, this is 2 again, so root 2. So therefore t1 we have is 2 plus root 2 or 2 minus root 2, but they are saying it is in the final 1 second it will travel h by 2. This is lesser than 1 second, it is not at all possible. So answer for this is 2 plus root 2, or we can take root 2 common, root 2 in bracket root 2 plus 1, or just rationalize this, root 2 plus 1 into root 2 minus 1 divided by root 2 minus 1. And again, if you just multiply this 2, it is a squared minus b squared you will get, that is 2 minus 1 by root 2 minus 1. 2 minus 1 is 1. So root 2 divided by root 2 minus 1. So 2 plus root 2 in bracket root 2 plus 1, or root 2 divided by root 2 minus 1. So these three answers are possible answers for this given question. Now the last question we have. A body is dropped from a height of 20 meter above the ground. If gravity disappears 1 second after it starts falling, the time taken by it to hit the ground. Okay, so one body is given which is dropped from a height of 20 meter. Gravity disappears after 1 second. In 1 second, gravity we have is 10 meter per second squared, but after that gravity is 0 meter per second squared. Okay, so at this point, whatever speed is there, that speed will be retained by this. So firstly, we have to find what is the distance travel, right? So distance travel S is equal to, we have 1 by 2, 10 into t squared is 1 squared, which is equal to 5 meter. So this distance we have is 5 meter. Next distance we have is 15 meter. So in this 15 meter, to travel this 15 meter distance, what is the time required? So time for that is distance we have 15 divided by the speed at that point. Speed at this point, how to calculate? V is equal to plus 80. A is 10 into t is 1, so we'll get 1.5 seconds. So the total time we have is time required for this 5 meter is 1 plus the time required for this 15 meter is 1.5, so which is 2.5 seconds. So the answer for this is C, that is 2.5 seconds. So I hope all these questions are clear to you all, right? So if anyone has any doubt, they can comment their doubt in the comment box. I'll try to reply as soon as possible. Thank you so much.